Hello everyone. In this video, we will do some examples involving varying annuities. Recall the expression we discussed in the previous video. For all these expressions, no matter we are dealing with the annuity deal, annuity immediate, or continuous annuity, we need to multiply a product of three terms: the present value factor due to the power k, or in terms of the force of interest, e to the power minus delta t, and then the payment amount, and then the survival probability KPX. All right, so this is the core of getting the actuarial present value. All right, let's take a look at the first example. Given that the force of mortality is a constant 0.01, and then the force of interest delta is 0.06, calculate these four annuities. All right, we need to get the survival probabilities. That is, in this case, TP20. The individual is at age 20. We have a constant force of mortality, 0.01. So TP20 is e to the power minus 0.01 times t. And then the first annuity, we have an increasing annuity due. This is a 2-year term. The payment, the individual receives a payment of 1 immediately. And then when the individual reaches age 21, the individual receives a payment of 2. From the first principle, we get the actuarial present value of each of these two payments and then sum them up. So we get this expression. And then upon calculation, we get the answer. The second part, a 3-year temporary increasing annuity immediate. And we have this payment pattern. The first payment, a payment of 1, is paid when the individual reaches age 21. And then the last payment is 3 when the individual reaches age 23. Getting the actuarial present value of this annuity, the first payment of 1. So we have the first term, a payment of 1, and then times the actuarial present value factor, e to the power minus delta times P20. And similarly for the second payment and the third payment. Doing the substitution, delta and TP20. Upon calculation, we get the answer. The next part, we have a 3-year term, annually decreasing continuous annuity. So in the first year, this is decreasing annuity. So in the first year, the payment rate is 3. And then in the second year, decreased by $1. And then in the next year, the following year, the final year, the payment rate is 1. And then we have this expression for the actuarial present value for this annuity. For each of these integrals, remember a product of 3 terms. So the payment rate, in the first year, a payment rate is 3. The second year is 2. And then the last year, the payment rate is 1. And then times the present value factor, e to the power minus delta t. and then times the survival probability, TP20, and then doing the calculation, we get the answer for this annuity, 5.5381. The last one, we have a 4-year term continuously increasing annuity. So the payment rate is a continuous function. Set up the integral to get the actual present value. So this is the integral from t equals 0 to 4. The payment rate is t. And then the present value factor, the last component, the survival probability, TP20. Set up the integral, and then we can do the calculation using integration by part. And here we get the actual present value for this annuity, 6.6524. All right, the next example. For a life annuity deal issued to an individual at age 45, the annuity payment, $5 at time 0, $10 at time 1, 15 at time 2, 20 at time 3, and then afterwards, $25 per year. And we are giving the following 4 quantities: the delta, 0.02, the survival probability, 5p45 equals 0.86, and then A.50 is 20. And then we have a 5-year term, increasing annuity due. The corresponding actuarial present value is 13.15. And then we are asked to find the actuarial present value of this annuity. Construct a time diagram. Starting at age 45, a payment of 5. And then at time 1, that corresponds to the individual reaching age 46, a payment of 10. And this is the payment stream. To get the actuarial present value of this annuity, we split the payment into 2 parts. Okay, the first part, from age 45 to age 49, this is an increasing annuity due with payment multiple of 5. So we have this actuarial present value 5 times IA:45 colon angle 5. And then starting at age 50, the payment is constant, $25 per year. Discount back to age 45, this corresponds to a 5-year deferred annuity due at age 45, and the payment amount is 25. Sum these 2 terms, and then we get the actuarial present value for this annuity. All right, so we have this expression. So we have the IA:, we need to get the 5-year deferred annuity due. So further decompose this as nu to the power 5, 5p45, and A:50. And here we get all the quantities. Nu to the power 5, we have the corresponding force of interest, and then 5p45, and then A:50. Doing the calculation, we get the answer, 454.83. All right, another example. For a life annuity immediate issued to an individual at age 30, The annuity payment amount begins at 10 for the first year and then increases at 6% per year as long as the individual survives. All right, so here we are dealing with a geometrically increasing annuity. Given that the force of mortality is a constant 0.01, the interest rate I is 10%. Calculate the actuarial present value of this annuity. Use the basic formula, the summation, and then the terms is a product of three terms: the payment amount, the present value factor, and the survival probability. The annuity payment start at 10 in the first year and then increase at 6% per year. So we have an expression for the payment BK equals 10 and then times 1.06 to the power K minus 1. And then KP30 is e to the power minus 0.01 times K, the constant force of mortality. Expand the summation, plug in the values. The first term, when K equals 1. So the first payment is 10 with the present value factor nu and then times P30 corresponds to K equals 1. The second term, K equals 2. The annuity payment is 10 times 1.06. The corresponding present value factor nu square and then 2P30. The third term, etc. This is a geometric series. And upon calculation, we get the answer. The actuarial present value of this annuity, 195.87. That's it for today's video. Thank you for watching and see you in the next video.